Bismillah, assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to answer some questions that students ask about them. The second question from May, June 2012 in paper 3, time variant 1. Okay, in this question, what they say, a girl rides her bicycle along a straight horizontal road, okay, level road, okay. The figure shows the graph of her distance time graph, okay? So level road, there's no going up or down, there is no change of gravitational potential energy, and they are giving us the distance during the time of its motion. Now what they ask, first of all, they ask us to describe the motion from A to B, from B to C, and from C to B. As you can see here, there is curve, that means the gradient increased it's a slope, the value of it increases. So that means in distance time graph, we know that the gradient represents the speed. And since the speed, the gradient is increasing, that means the speed is increasing. That means here it's on what? On acceleration. That's from A to B. Now from B to C, as you can see that it's a straight line. That means constant gradient. So that means we can say steady velocity. The velocity doesn't change, or steady speed, okay. And third thing, okay, third part here, they ask about from C to D. As you can see that the gradient or the start to decrease, eventually it becomes something like horizontal. That means it deceleration until it stops, or you can write deceleration only. And like this, we can get the 3 marks on this question. So as you can see, as in distance time graph, the gradient represents the speed. As the gradient keep increasing, it's steeper. That means there is acceleration here, get lower speed, lower speed because the gradient is get less speed. Okay, but here from B to C, it is a straight line. That means it's constant speed or steady speed. That's part A. Part B, calculate her average speed from A to D. Her average speed from A to D, as we know that speed is equal to distance divided by time. So how far is the total distance from A to B? Okay, A to D, it's 400 meters because they ask about the average speed. The speed keep changing. Divide by the whole time, which is what? 60. By using the calculator, the answer is 6.65. So yeah, 6.67, sorry. So 6.7 meters per watt per second. Then the question asks about the maximum speed. When they ask about the maximum speed, that means the steepest line. The steepest line, that means it's the line from B to C. We can choose any 2 different points, or we can choose the points B and C directly. Okay, and we find the gradient of them. Okay, and after knowing these coordination, as you can see here, it's 70. And here it's 350. That's the rise. The run, it's 45 minus what? 15. So by using the formula that speed of the maximum equal the gradient, which is equal the rise over the run, which is as you can see 350 minus 70, 350 minus 70, that the change of the y-axis over the change in the x-axis, which is 45 minus 15, 45 minus 15. And by using the calculator, okay, it will be 350 minus 70 divided by 30, and the answer is 9.3 meters per second. That's the first question. We did it. Okay, next question is the first and the second question from May, June 2013. The first and the second question in May, June 13. The first question, it's an easy question. The defined density, it's mass per unit volume, as all of us knows. Okay, density is mass per unit volume. It's a definition formula. Okay, density per mass over volume. The density of aluminum is given. Okay, the thickness of a rectangular sheet of aluminum foil varies, but it's much less than 1 millimeter. So we don't know how much is the dimension for it, but it's much smaller than 1 millimeter. Then what they said, a student, okay, which is to find the average thickness, okay. What she did, she obtained the following measurements: the mass, the length, and the width of what? Of this metal sheet, okay, aluminum sheet, and she did some calculations. They asked for the volume and the average thickness. Now the volume, most of the students, they think that the volume equal length times width times the thickness, and the length is given and the width is given and the thickness is much less than this value. Let's put it this value. No, that's not correct method to answer the question, because we have the density, and so that means we know that density, okay, Greek letter rho, or you can write capital D, doesn't matter, equal mass over what? Volume. We ask about the volume, so we can put it as a subject of the formula. Volume equal mass over density. Let's substitute the mass, which is 60.7, divided by the density, which is 2.7, and the answer is approximately 25. Let me check. 60.7 divided by 2.7. Yes, 22.5. 22.5 centimeter cube, cubic centimeter. Okay. Now, why we put it centimeter cube? Because they give us here in grams, centimeter, even the unit in gram per cubic centimeter. Then they ask about the average thickness. Now, in this situation, we know that volume equal length multiplied by width multiplied by the thickness that they ask about it. So thickness equal volume divided by length multiplied by width, which is equal to the answer that we just find it out. This is the volume, which is 22.5, divided by the length and width from here, okay, which is 50 multiplied by 30, and the answer by using calculator 0.015 centimeter, which is much less than 1 millimeter, as the question said, because 1 millimeter is 0.1 centimeter. So this value is much less than 0.1 centimeter, which is 1 millimeter. Okay, easy, as you can see. Next question, what they ask. Next, they ask another student provided with the means of what cutting of sheets, the sheets, okay, decided to find the average thickness by using a single measurement instrument. Okay, assume that the surface of the metal, they are smoothly perfect, okay, perfectly smooth. Say the name of this instrument. This is called micrometer. Okay, micrometer screw gauge, or you can write micrometer. Okay, part I, describe the procedure she should follow to obtain an accurate value for the average thickness. Okay, they didn't ask about how we can take the reading. Okay, 3 marks. First of all, we have to what? In any instrument, okay, in any instrument, we have to check the zero error. First, check the zero error, of it, of the micrometer. Then measure the thickness of 10 sheets. Then divide this thickness by how much? By 10. Divide this thickness by 10. And that's how we can answer the whole thing here. One of the questions they asked me about the differences between speed and velocity. Now, to realize what are the difference between speed and velocity, we know that this is a scalar. That means it's only magnitude without direction, but this is what vector, that means it has direction. Now, how we can find the speed? We know that speed equal distance divided by what? Divided by time. Okay, while velocity, it's displacement. So displacement, okay, it has what? It has direction, and they don't ask about it usually, okay? in the IGCSE syllabus, but we have to realize that, for example, if a kid moves from position A to position B, then to position C, okay, and eventually goes down to D, which is in the same level of A, like this, and they give us, for example, the dimensions and the movement, for example, 2 meters up, 6 meters right, okay, then 2 meters down, okay, and they say that it takes, for example, here 1 second, here it takes, for example, 3 seconds, here also 1 second, and they ask about the distance, they ask about the speed, or they ask about the velocity. We can write here that, I'm sorry, we can write that here the speed, the average speed is the whole thing that they move 2 plus 6 plus 2 divided by the whole time, which is 1 plus 3 plus 1, which is 5. So it will be 10 divided by 5. So it will be 2.0 meters per second. While the velocity, we are not talking about that. We are going to talk about directly from A to D directly, which is 6 meters. So velocity equals 6 meters. The displacement divided by the same time, okay, which is the whole time, which is 5. So the answer, it will be 1.2 meters per second to the right. Okay, but they don't usually ask this in the IGCSE syllabus, only for your information. Okay, one of the questions they ask you to compare between speed and velocity and how we can calculate that. Okay, another question that they ask about it, it's question number 2 from the same year. What they ask, okay, first of all, underline the vector quantities. What that means of vector quantities, that they have what direction. And if we said about direction, only the velocity and the force, they have direction, while density, energy, mass, volume, they don't have direction. So like this, we get what our 2 marks by underline the force and the velocity. Next part of the question, part B, they ask about what? They ask about a small metal ball. When they say the small metal ball, that means there is no air resistance. So that means we neglect all resistance, only the weight acts on it. Only the weight acts on it. Okay, so because they said that a metal, okay, a small metal ball is projected into the air with an initial velocity of 40 here, okay, vertically upwards. The graph shows how the velocity change in the time until it reaches what the maximum height, until here which stops at the maximum height. As you can see, it's a straight line that's going down. That means the velocity is decreasing at uniform rate. That's why they call it uniform deceleration. And this deceleration is caused by the weight that acts down, and that's caused by gravity acceleration. So that as gravity field strength, that means that the acceleration or the deceleration here, it's equal to the gravity acceleration, but it's negative. That's why its deceleration is going down. Okay, so what they ask, use the graph to find the time until it reaches this, okay, maximum height. It's approximately this point, which is 4.1 second. Now they ask about the deceleration. Now we know that the deceleration or the acceleration, it's equal to the negative of the gradient, okay, because they ask about deceleration, but we find the acceleration, so we will neglect the negative sign, which is the rise over the run. So the change in the y-axis, which is 40 minus 0 divided by the change of the x-axis divided by 4.1. And by using the calculator, 40 divided by 4.1, it's approximately 9.8. 9.8 meters per second square. It's supposed to be 10 approximately, but 9.8 is more accurate. The answer is 9.75, blah, 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 but we rounded to 2 significant figures. Okay, so that's why the gravity acceleration is equal to the same. The deceleration here is equal to the gravity acceleration. Triple I, they ask about the maximum height, they ask about the distance. And we know that the distance is equal to the area under the graph until it reached the ground, so here. So the height of this triangle, it's 40 and the base is 4.1. So the area of that, it's equal 40 multiplied by 4.1 base height divided by 2, or half base height. And the answer is 82 what meters. The distance is supposed to be meters. Those teachers said, why they said area, why we put meter? Because I'm not talking about area, I'm talking about distance. Area of the graph, okay, which is a multiple of velocity over time divided by time, meters per second divided by second. So second with second, when we multiply them, they cancel out each other. So that's what left. Finally, see on the figure, add a line to show what will happen to the velocity as change after it reaches the maximum height. Now, actually, it now starts to fall down. The negative velocity and the acceleration remains the same. So I will use my ruler and continue this line as a straight line like this. Okay, it's supposed to be straight line. Forget my handwriting here. Okay, so it's supposed to be a straight line by my ruler. I will continue this line to be what? To be straight, to have the same what? Gradient. Okay, and that's it for now. If you have any question, this is Dr. Ahmad Al Faris. You can ask me at any moment. Assalamu alaikum wa rahmatullahi wa barakatuh.